are forcing me to move on here. Oopsies.
Yes, we definitely will.
So you can predict as much as you'd like, but we're going to see what the weather means. You're going to my website under Unit Docs. Okay, under Unit Docs. Don't close Socrative. Just keep it there. Nope. I got it from here. You good? Unless you want to teach today? I'm getting paid to teach, so let me do it, okay? Alright, so under Unit 8, click on Collision Theory and Intro to Equilibrium WebQuest 2015. So when you click that, a Word document will come up. So the Word document requires you to first watch a TED-Ed video. We're going to watch the TED-Ed video together first, and I'm asking for approximately 10 bullet points of information. If it's not a full 10, it's fine. I'm going to write some on the board too, so we can kind of tag team that. And we may not do the second part where it talks about a quiz, because we'll elaborate during our bullet points, so we won't have to do that section. So I'm shortening this for you right now. Are you ready?
Ready.
Okay. Collision Theory, WebQuest Part A. All right. So writing this down with me, okay? Part A.
Meet our chemist, Harriet. She has a chemical reaction that needs to occur more quickly. Our chemist has some processes at her disposal that can help her speed up her reaction, and she knows of 5 ways. And to remember them, she thinks back to her days as a high school student. And
All right, what does she want to do with her reaction? Speed it up. Okay, so these are 5 ways to speed up a reaction. RXN is my abbreviation for reaction. Cool?
Wait, so you just want this with the bullet list?
Yeah, so I'm just going to writing my bullet points in like a table format.
day she got a date for the dance. Harriet was in high school studying between classes. She had lost track of time and was going to be late to class. Unbeknownst to her, Harold, who was just around the corner, was running late too. They both sprinted to class, and as it happened, sprinted directly into one another. Now, this was no small collision. They ran squarely into one another in such a way that he knocked the books right out of her hand. "I'm sorry," he said. "Let me help you with your books." He kindly helped her recollect her belongings and politely offered to walk her to class. And you'll never guess who went together to the dance later that year. Yep, those two. So as we can see from this example, the key to getting a date for the dance is to collide with someone and knock the books out of their hands. Now, you're probably already aware that not all collisions lead to dates for the dance, thankfully. The collisions must have 2 important
Okay, so you saw about collisions right now, right? So, and this is kind of just a thought, but that it's all analogous. It's an analogy between like getting a date for the dance and like making a reaction happen. So collisions must occur for a reaction to happen. It doesn't just happen out of nowhere. Some reactants, molecules have to collide. Now he's going to talk about 2 characteristics or 2 factors those collisions must have. Okay? 2 factors or characteristics that collisions must have.
characteristics. 1, correct orientation that allows books to be knocked from one's hands, and 2, enough energy to knock the books out. Shortly after the...
Okay, what were the 2 factors?
Energy.
All right, I heard correct orientation. That's 1. Oops, that's just 1. And then the second one was enough energy. All right, so this isn't a fact. These aren't like one of the 5 ways yet. He's just talking in general about collisions first. And now he's going to start with 5 ways. So this is kind of like an intro. So for reactions to happen, they must correctly collide and have enough energy in that collision.
This incident, Harriet decided to tell me, her chemistry teacher, all about it. I noticed some interesting parallels between her story and chemical reaction rates, which happened to be what she was studying in the hallway the day of the collision. Together, we decided to set out on 2 missions. Harriet wanted to help all chemistry students and chemists remember how to speed up the rate of chemical reactions, and I, being the nice guy that I am, decided to make it my mission to help create educational environments in which more book-dropping collisions can take place to increase future chemists' chances of getting a date for the dance. In order to facilitate this improved dance date-getting process, I proposed 5 changes to all schools that parallel Harriet's 5 ways to increase chemical reaction rates. First, I proposed that we shrink the size of the hallways. This will make it more difficult to safely navigate the hallways and will cause more collisions than in larger hallways. And by increasing the number of collisions, we increase the likelihood that some of those collisions will have the correct alignment and enough energy to create a date to the dance. Now, chemically speaking, this is equivalent to lowering the volume of a reaction vessel or a reaction mixture. In doing so, the individual particles are closer together and more collisions will occur. More collisions means a greater likelihood that collisions with the appropriate energy and configuration will happen. Second,
Okay, so he just mentioned minimizing or decreasing the size of the hallways. But that's like the school example. What's the chemistry example he mentioned? All right, so decrease the volume of container. And the reason behind that is because it will do what particles?
Collide.
Bring them closer, which makes them more likely to collide. It's all about collisions, right? It's called the collision theory for a reason. You have to mention the word collision to really get the point of what's happening. So decreasing the size of the container will increase number of collisions. And if you can make stuff collide more, you're going to speed up that reaction. It's all about how often they collide.
I propose increasing the overall population of the school. More students equals more collisions. By increasing the number of particles available for collision, we create an environment where more collisions can take place. Third, we must reduce the time allowed between classes.
So fast, okay. So, increasing the population of school relates to what in chemistry? More moles or more particles, more grams, there's just more stuff, right? Grams, particles, moles, whatever you want to call them. I'm going to say increase number of particles because we are speaking like on the particle size, like on that scale, particles, and that will cause an increase in number of collisions, right? So we have like 20-ish people in here. If you guys were just roaming around this half of the room, you guys would collide, right? And then if I gave you the whole room to roam around, would you collide more or less? Less, because you're spread out, right? Okay, so that's the volume one. If I contemplate 50 more people in this room, what would happen to the number of collisions if we walked around? It would increase a lot. It's just particles. Hey, we only have so much space to play in, so if you have a number of particles and you increase that, you're going to increase those number of collisions, which would then speed up the reaction.
School.
Oh, sorry.
More students equals more collisions. By increasing the number of particles available for collision, we create an environment where more collisions can take place. Third, we must reduce the time allowed between classes. Heck, let's just cut it in half. In doing so, students will need to move more quickly to get from one class to the next. This increase in velocity will help make sure collisions have the appropriate amount of energy necessary to ensure book dropping. This is analogous to increasing the temperature of the reaction mixture. Higher temperature means particles are moving faster. Faster moving particles means more energy and a greater likelihood of reaction causing collision. Fourth.
Okay, so that was, what was the chemistry example here? Increasing or decreasing, but since we're talking about speeding up on increased temperature. So temperature does two things, and that's why this one's going to be a little longer, it's more expansive than the first two. Increasing temperature is what causes the velocity of particles to increase. And that was like what we talked about with gases. Like increasing temperature, more kinetic energy, they move faster. So if you were walking around the room, let's say maybe you would collide with 2 people. If you were running around the room, how many people do you think you'd collide with?
3.
3, 4, 5, 10, I don't know, more, right? So if you're faster, you're going to collide with the particles more or less often. More, okay? So I said increasing temperature increases frequency of collision. But if you're walking, you're just gonna like bump into somebody, right? It's not too bad. But if you're running, you're gonna have a concussion, right? You're gonna like bombard somebody. So what was he speaking to that in terms of the particles? When they collide with more force, more energy. So they're gonna meet enough energy. Because if you're just walking, you may not have enough energy to react. Just a little bump here or there, nothing really. But if you run and you hit something really hard, you're going to have enough energy to react, as it is in the chemistry sense. So not only increases frequency, but it also increases the energy of the collision. So temperature has a 2-part kind of explanation. Increases frequency and energy.
Students must stop traveling in packs. By traveling in packs, those students on the outside of the pack insulate those in the middle from undergoing any collisions. By splitting up, each student has more area exposed that is available for a collision from a passing student. When particles travel in packs, the surface area is very small, and only the outside particles can collide. However, by breaking up the clumps into individual particles, the total surface area is increased, and each particle has an exposed surface that can react. Fifth, and finally, we hire a matchmaker.
Okay, so that example here, he was talking about powdering or like taking these particles and splitting them up. So who's ever seen like a deer salt lick? liquid. Like, it's just a big block, right? It's like a block about this big. And how many sides are on that cube, that block? 6. So there's surface, 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 surface. That's it. So the deer's gonna be there forever because there's not a lot of surface area, which is good for whoever wants to see that deer for some reason. So, like a deer, like a. Okay. So, how would one increase the surface area of a block? Cut it in half. Then it has a total of what? 12 sides. Okay, right? Keep going. Break it, break it, break it, break it. You could take it all the way down to particle size or powder, right? So like grinding it up in a mortar and pestle. And that's going to actually exponentially increase the surface area because you have every single teeny, teeny particle with 6 sides. And then that would be like that times a billion, which is actually much, much larger than the original. All right, last one.
Is increased, and each particle has an exposed surface that can react. Fifth, and finally, we hire a matchmaker. Is this colliding and book dropping too violent? Is there an easier way to get a date that requires less initial energy? And a matchmaker will help with this. The matchmaker makes it easier for a couple to get together by coordinating the match. Our matchmaker is like a catalyst. Chemical catalysts function by lowering the activation energy.
Chemical catalysts function by lowering the activation energy. That's what I would write. Because a catalyst is something like you've heard about in biology, right? What were catalysts in biology? Say again? Right, enzymes are examples of catalysts in biology, and they're all in your body, and they speed up a reaction. Well, we knew they speed up a reaction. We've heard that probably for 2 years now. But how they speed up a reaction is this reason right here. They speed it up by lowering the activation energy, and that's something you're going to see a little bit more in the web quest. It's just the energy that's required. So if 100 kilojoules are required, not many reactions may meet 100 kilojoules when they collide. But a catalyst might lower it down to 50 kilojoules required, which would be more approachable, more doable for a lot of collisions.
In other words, by lowering the energy required to start a reaction. They do this by bringing 2 particles together and orienting them correctly in space so that the 2 can meet at the correct configuration and allow a reaction to take place. So to sum up, if a future chemist wants a date for the dance, he must collide with another person and knock the books out of their hands. And if a chemist wants to make a chemical reaction occur, the particles must collide in the correct orientation with an appropriate amount of energy. And both of these processes can be accelerated using the 5 methods I've described.
Alrighty. Alright, so for those of you who are at the point to move on, we have completed A together. No need to go here. This takes a long time to do the quiz. So you can move on to B. If you're still in the middle of the quiz, that was the acid-base one, go ahead and continue that now. Okay? A couple of the ones we'll talk to you. So if you don't have earphones, I do have the headphones still. You guys can borrow those. Lastly, a couple of them will not work on Chrome. Sad, but Firefox Flash Player will work. You said in the lobby area. Yeah. Good question.
It's got in the pH. How do you lawn.
You didn't know?